Welcome to this section of Theory of Projection of Solids. In the last section we have seen an introduction to projections of solids and different types of solids like prisms and pyramids. And in this section we are actually going to see how we'll be able to draw the projections of solids on a sheet of paper. What are the techniques used and how to proceed. So what we learned here, we learned techniques to draw projections of simple solids. Then we also learned how to show projection of solids in various orientations with respect to the horizontal and vertical plane. And some tips to think about. All orientations and distances with HP will be seen in front view, and all distances and orientations with VP will be seen in the HP. This is something which we already have learned when we learned projection of lines. And one more thing is tilting of solids can happen with respect to a corner, edge or face. This we have seen something about this in the first section. That is introduction to projection of solids. We have seen how a corner looks like and how a slant face looks like and all. And these corners, edges and faces, as we said, it could be part of the base of that particular solid, or it could be the vertical and slant portions as the case may be. So let's see how we can proceed with projection of solids. So what you see on screen is a square pyramid sitting on a plane, and we are trying to draw projections of this solid, that's this square pyramid, so that it is tilted at some angle to the horizontal plane. So before doing that, let's see how a square pyramid looks at different orientations. So let's tilt and look at it from the top. So this is how it looks at the top. So from the top, and obviously these lines represent the base edges, and these slant diagonals represent the slant edges of the square pyramid. The straight edges are the base edges and these are the slant edges. To get a much more clear understanding, let's look at it in 3D. So you could see that as I tilt the solid and look at different orientations, some edges are seen and some are not seen. These obviously are known as called as hidden edges, and these are the visible edges. So as a quick tip, I could tell you that while drawing projections, one of the most important thing you'll have to look at is a boundary of your projection. When you look at a solid, the boundary edges always will be seen. I mean, the boundary edges are something which you can draw using straight lines and continuous lines, and these lines actually inside are going to be hidden. This could be seen even if you, as you rotate the solid and look at different orientations, this will be much more clear. And again, let's see how it will look like if we try to tilt this solid with respect to the horizontal plane. So we are going to tilt it. So now you can see the solid is being tilted with respect to an edge here. So as I told before, this tilting can be done with a corner, with a base edge, or even with a slant edge or slant face. So to put in a different way, this question, so for example, this question could be asked in multiple ways. In fact, that is, the same question can be said like a square pyramid with say height 100 mm and base 80 mm is tilted with respect to its base at an angle of 30 degrees to the horizontal plane. This is one way it could be said. Another way it could be said is that the same square pyramid, the axis of the pyramid is tilted at an angle of 60 degrees with respect to the horizontal plane. Both are same, in fact, since the axis and the base, they are perpendicular. So if the base is tilted at 30 degrees, naturally the axis has to be at an angle of 60 degrees. So this is something which you have to be aware of while doing projections of solids. And so with that introduction, I think we'll also see how we could actually represent this in 2D. And one more thing, when we look this solid from the top, for example, if you look from the top, you could see it looks quite different than when it was when the axis was perpendicular to the HP. So here you could see that these faces, there are only 3 faces you can see. The 4th face, which is on the other side, the 4th slant face on the other side, is completely hidden, and you could see that this edge, with the edge with respect to which it was tilted, that's also hidden. So this is how it looks like. And so again, it depends on which orientation you are looking at. If you are looking at from this side, it will be entirely different kind of projection you are going to get. So let's straightly dive into the technique of drawing projections for the same square pyramid in a tilted position. So let's see how we can draw the square pyramid on a sheet of paper using the techniques of projection. So as you see here, we have started with the XY line. We have drawn the XY line, and then we have continued to draw the projections. So, and we have to mark the different points on the solid. So initially we'll start by drawing the square pyramid, and while drawing the square pyramid, the question, it might be said that it is at a particular distance from the vertical plane. In that case, we'll be drawing this edge at the given distance. Say if it is 20 mm, we'll take 20 mm below XY, start drawing this edge and complete the square, and draw the diagonals to represent the slant edges. And next step would be to project all the corners, starting with the axis first, to project it straight up above XY line like that. And then what we do is we mark the axis height as given from the XY line to the required height. Then we, from that point, we join to these 2 end points, which are nothing but these projections from this square. So that completes the front view and top view in simple position. So this is simply now the solid is simply sitting on the horizontal plane. Now in our example, what we have seen is this solid is going to get tilted with its base having an angle of say 30 degrees with the horizontal plane. So we might mark the angle also here, it's 30 degrees. And then the next step would be, now we have tilted the position. Whenever we draw projections, the tilting position has to be shown in front and top view to get a complete picture. So to do that, so what we do is we project lines after tilting this solid here. The next step is draw projections or projectors from every corner or every point of the projection like this, and similarly draw projectors from the top view towards this side. So where the corresponding points meet, that will be joining. So for example, let's mark these corners as A, and say B, this is C, and this is D, and this could be the corner apex could be O, and the other endpoint could be P, something like that. So this and this could be, this we mark as O dash, P dash, and this as A dash, B dash, and this as C dash, D dash, this particular point, and this center point will be OP. So we have marked the points, and we correspondingly we have the corners marked here as well, O dash, and this is P dash, and this is A dash, B dash, and this again is C dash, D dash. So in another way, you can say that this particular pyramid is being tilted with respect to the edge C dash, D dash. So now let's try to see AD is coming in this direction, and we have A coming here, so you probably can put a point there. So we have a point there, and here we have a point, here we have a point, because B and B and C and C. Similarly, if I draw this line, that is nothing but P, P dash and P, so there will be an axis point here, O dash and O, another point here. So we can mark, we can start joining the points now. So we have A and A at this, and C, and you have D and D here, and C and C here. So we have A, D, D, C here, and O here. So what we do now is we go ahead and join these outermost points like that. And normally the outermost bounding lines should always be drawn with continuous thick lines. They're called continuous thick lines. And now these lines, actually when you join them, they have to be, you can draw these lines as well here. So when I try to draw the lines here, and this also, so totally you have now so many edges. So this is how we typically draw, and these edges will also be darker. So this is how we draw the projection. And you could see that this line, this edge, is going to be a hidden edge. So for that, what we do is we draw that edge, obviously, and we will have to make it a hidden or dashed line. By making it dashed, it will be clear. So this has been converted into a dashed line. So while drawing projections, the dark and the continuous line should be much distinct from these projection lines you have drawn. So otherwise won't be neat, and at the same time it would be difficult to someone to find the difference between your projection lines and the actual projection. So this has to be something which you'll have to keep in mind. So probably initially, after locating your points, you will have to slightly give more pressure while you draw using your pencil. Slightly give more pressure when you draw these outer bounding continuous lines, and with light pressure you can draw the projection lines. That is one method. Another method is use 2H and H pencils. So these are some things which will be taught in class. So you can go ahead even marking the corners here. So you can say that this could be A here, and this could be again B, and this will be C, this will be D, this will be O, and in fact we have not drawn the axis point. The axis point will be somewhere here. So this P correspond to this P dash, and so this is OP. Fine. So in fact we can also draw the axis. For example, let us do that. Let's draw a line from this to this and make that a hidden or dashed line. So now that becomes the, in fact that has to be not a dashed line, it has to be a center line. I'm sorry, it has to be a center line. This should be center line and the hidden lines should be dashed lines. So you can see that center lines normally are represented by a dash and a dot. You have a dash, you have a dot, you have a dash, you have a dot. Or there is another way where you have big dash, small dash, big dash, small dash. There is also another way of drawing the center line. So always center lines axis, they have to be drawn using dash dots. So that gives you probably some idea of how we proceed with a solid in a simple projection. So next we'll be seeing how solid can be drawn when it is oriented simultaneously to the horizontal and vertical plane. Here we have seen a case where the solid is, one of its faces is tilted at an angle, but we'll also see another case where it is tilted to the vertical plane as well. So how it is going to be looking like. So far we have seen how this pyramid is being tilted with respect to HP. Now let's see how it will look like when we tilt the same solid with respect to VP. For example, let's take the case where this edge is being tilted with respect to the vertical plane at an angle of say 30 degrees. So let's see how it's going to look like. So it is going to look like this when it is tilted from the top view. So what you could see here is regarding top view, the view is going to be the same, only thing the view is tilted, otherwise the whole view was much similar, or in fact identical to the earlier case when that edge was parallel to VP. So however, if you look at the front view, that looks quite different. So that is the front view. So when you look from the front, this is how the pyramid is going to look like. And when you look from the top view, this is how it's going to look like. And to make it more clear, let's go back again and see. This was the old top view and this was the old front view. And now when we tilt, this is how the front view is going to change when it is tilted. So that's the difference. So now let's implement this in a sheet of paper. So here I have drawn this top view in tilted position. So I'll quickly demonstrate how this is actually done. So when you do this, a couple of things you have to be careful, like the first confusion people have normally is where I should start. I mean, how I should start drawing this, which is a point I should start tilting and stuff like that. So in this case, it is probably a simple one where since the axis is parallel to this edge, and since this is edge with respect to which we are tilting it, so we can easily draw this axis. You can start anywhere in this area. You can start drawing a line like this, and simply on your divider, when you draw manually, you will be taking these distances of points A, B, C and D and mark them with respect to this axis perpendicularly, since all these points lie perpendicular with respect to this axis. So perpendicularly you can draw lines based on this axis point. Suppose we mark this point as the axis, and from there you draw lines to this point. You take this particular distance on the divider, mark this point. Similarly, this distance on the divider and mark this point, and draw perpendiculars, and again take these distances, that is this particular distance, and mark here and corresponding here and here, and you can join and draw the projection of the base. Then you can also take the distance OP, and from this point to this point you can mark that, and you can completely join and create the tilted condition. So only thing, now you draw the axis with respect to the required inclination, take the points, mark the points on the divider from this earlier view, and simply transfer it here. So this is how you draw the tilted condition. Now the next thing is, as we did before, we simply project the lines or projectors from different corners. So for example, we will have to draw the projectors here as well, and then the next thing would be to see where the corresponding points meet. So we also have this point to be drawn, and now the next step would be to join them. So if you look at, this is point A, B, C, D. So A and A will be here. So here will be one point, and correspondingly B will be, in our case, because B is here. So let's start marking the points. So this is A, this is B, this is C, this is D, and this is O, and probably this is point B. And now this is A and this is B. So you can start drawing like that. This is A, this is B, and we can draw this point which is C, and this point which is D, and we can join the corresponding points, for example. So this is AB, C, D. So that is how the square is going to look like. And now we also have this point O. So we mark all the edges like this. So that is clear. Now we will try to make the outside boundary as dark as we did before, and we also have this edges, all the visible edges will be marking with continuous thick lines. And then, as you know, that this edge, the farthest edge, that is OD, which is this one, is definitely going to be hidden from view. So we mark, we draw that edge there, and we again make it dashed line. So this is how we'll draw the projection. This is similar to what we have seen in the 3D. So this completes the next tilting as well. Thank you.